Alright, my name is Richard Turan. I'm here to do the training on the Caliber 1 system. First thing we go over is the components for it. Of course, you got a computer, holds your software, SPM Lab 604 that runs this microscope, interacts with the controller, which is the ECU Plus model. From there, it interacts with the Caliber head via the brick. And then from there, we got the actual Caliber head that does all the X, Y, and Z scanning. Now on this head, we adjust the laser alignment using these two knobs, and we use this to move the laser onto the probe so it can reflect off the probe onto the detector, which we can then use the detector knobs where we can align the laser reflection on the photo detector to get maximum sum. On the top of the head, we have these two screws actually that you can use as manually lowering or raising the head onto the surface. The one at the rear is actually a dummy screw. That's just a cap where the Z motor is actually below. The smaller one is for the fine focus of the camera inside the Caliber head, while the one to the side right here is the one to move the camera up and down on the video screen, while the one way at the bottom is the one to move the camera left and right on the video screen. And then this is the stage for the Caliber head. It has an X and Y translation knob right here. In the middle, it has a magnetic sample holder which holds on metal pucks. From there on, we're going to go over the process of actually turning on the software and going into contact mode. So the first thing you want to do is actually have the computer on first. After you have the computer on first, you want to turn on your controller using the power switch right above the power plug. Once you turn on, you got to make sure all the LEDs light up of the 5 all the way to negative 225 volts. From there, we want to turn on the video window labeled WinTV 2000. And you want to keep that on your left screen. Once you have the video window open, you can turn on the software for it, which is SPM Lab 604. Just double click that, you should get it to pop up. Say I accept the license agreement, and then go to this icon that is a cross section of a probe and some sample to go to real-time mode. But the first time you do it, it will go to scanner selection. The first thing you want to do is select the CASW lin file, which is the Caliber software linearized file at the top, and click OK. Then hit engage. You should hear the relays on the controller turn on. And we won't use a linear file. The reason we use a linear file is to balance out the resistors on the piezos to the matching resistors on the Caliber interface box, the brick. Before you open up that window, you got to make sure you're in the 1 micron scan range. So using the drop-down menu, select 1 micron. Sorry. Then you can go to the setup XY alignment. The only ones we're going to adjust are the X and Y using the software linearized file. To do that, on the brick, on the side of the brick, there's an X, Y, and Z. There's X, Y, and Z holes. Inside those holes are actually screws for adjusting the pots. What you want to read is at least 2.3 volts for X and Y, so adjust. Being very careful not to push too hard on the pots to where you can actually break them off the circuit board until you read 2.3 volts. us to 2.3 volts. We can close the window. Go to setup. Go to scanner select. Click continue. And go to scanner changed, which will bring back the scanner selection window from earlier. Now this time we want to use the CAHW lin file, which is the caliber hardware linearized file. And then click OK. Click OK again. And engage. Now we got to go back again and do the setup XY alignment. We'll do the same thing as we did with the software linearized file, but this time we're looking at Z. So we adjust the Z linearized number until we're as close to 0 as we can, plus minus 100 millivolts is fine. And the same way you adjust the X, Y, you do the Z. We're already close to 0 right now, so we're good. Now we can add a probe into our microscope. So this one's for putting the probe into our Z scanner. So the first thing we do is flip over the head. And if the laser is on, turn it off using the laser off button right here on the screen, which it was. We're going to use the probe. I don't know if you want to get closer on this one. So these half moon pre-mounted probes have a hole in them, so you can drag them across all the way to the edge. So you can be able to pull it off this magnet. Hold it from one side. Close your box up again. That way you keep any kind of dust or anything onto probes. With the probe in hand, with the tweezers, you have your Z scanner. In the Z scanner, there's two magnets that will hold your probe in place. Actually, put it pretty close to alignment. So you just bring it up closer and just let it grab on. Use your tweezers to kind of like adjust it to where it's perfectly straight, and at least parallel to the back of it. But don't push hard on this because this cap is very, very sensitive. It's easily broken if you push on it too hard. See, I can show it right here. This is actually your camera. To the right, directly opposite is your light. So now that we've got it mounted, we want to move the laser onto the tip of this probe. To do that, we'll use the video image on the WinTV 2000 and then turn on the laser to try to get that laser light onto the tip of the probe. So we'll flip it over and place on this XY translation stage, which we already have a sample on, a calibration sample on. When you place the head onto the XY translation state, try to place the motor part first in the circular part on the stage. And then after you have that in, put the right side of it onto the two bars right here, right between the two bars. So after you do that, you want to be able to look as you lower it onto the probe, which we can't see right now. So until you're able to see it, you can move the probe until it's in focus. Then lower it, making sure you're not going to hit the surface. So close. And we didn't hit it because we can still see the shadow underneath. So the video image won't work very well on non-reflective samples. So try to have, if you don't have a non-reflective sample, it's going to be a little bit harder. First thing we're gonna do basics of just getting into contact mode. So we want to be able to put the laser on the probe and then line it until we get it right in the middle. I'm gonna go through the steps. First things we want to do is focus the probe as sharply as we can using the top knob. And that's pretty good right there. After that, we should go into the setup video window. Go to setup video. And you can do adjust the intensity of the light so it's not too dark that we can't see nothing, but dark enough to be able to see the laser. So right now we can't see anything because we haven't turned it on. Go back into the software. Down where it says laser, go to the laser window right here and click on high. Never click on low. Low has no function. So now we can see the laser on the video screen, and here's the probe still. You can still distinguish the probe right here. So we want to use the two laser knobs on the head to move the laser onto the probe. This is more of a skill you'll have to pick up, how to walk it, the laser onto the probe. Once you get the laser on the probe, pull out both knobs. It's like disengage the screws onto. Go where it says detector signal, right below the laser window, and click on sum. So after clicking sum, let's make this a little bit bigger. We left click on the oscilloscope window, the top oscilloscope window, and you see we have no sum at all by looking at the RMS number right here. So the first thing you do, one thing I usually do, is put my left hand on top of the caliber head. That way it doesn't move around the stage if we start moving around these knobs. And then move the top bottom knob, which is the bigger knob. And try to adjust that until you see some sort of sum. Or this where you can actually see a maximum sum. So you'll see it increase. And it'll come back down, so we go back up. So once we got the laser on the probe, we want to switch the detector signal to sum, the sum value, right here. Once we have it on sum here, the oscilloscope, we want to left click on the oscilloscope, and you'll get this vertical line going across it. This will give us the readings on the oscilloscope. And right below where it says T, you'll see a value, we're in nanoamps. That's our sum value. Right now it's 0, so we're not aligned at all. So the first thing we want to do is put your left hand over the caliber head. That way it doesn't move around the stage if we're moving knobs. And push down a little bit, and move the top bottom knob, which is the bigger knob, because that one causes the most effect on your sum value. So we want to adjust that till we get the highest reading on our oscilloscope, which will read right here. Okay, so we got 24.8 nanoamps. After you do that, pull the top bottom knob out. Now right click it and and left click on the left right knob. And the left right knob is right at the bottom. We want to adjust that line until we reach 0. So again, hold down with your left hand. And then right behind the top bottom knob is the left right knob. It's a smaller one. Move that until we get 0. Good. Pull it out as soon as you're done lining it. Go to the top bottom knob now. Top bottom signal on the detector signal box. And do the same. So this one's like super sensitive. And pull it out again. Because the angle of the mirror might be a little bit off, you might have changed your left-right alignment, which you did. So go back to left and right and readjust. So readjust them both until you get to a point where they're both aligned. That's good. That's good. So leave it in your top bottom signal. Selected. Leave it in top bottom signal selected. Now we want to do a deflection signal on it. Set up a set point for it. Something like this probe. We might want to do like 20 nanoamps. So we'll select, go to set point, highlight it, do 20. Press enter. So we'll update. We'll do a drop down. We'll do a 20 micron on the scan range. Scan rate will do about 3 times the scan. The scan rate should be about 3 times the scan range. 60. Resolution 300. Proportional gain 5, and then integral gain 0.5. Good starting gains. And 0 derivative, 0 sample bias. After that, we can hit tip approach. Leave it in the top bottom signal. And you want to do to reduce the waiting time for engaging. Manually bring down your probe using the motor control buttons up here at the top. So one thing will make it move up, and then one thing will make it move down. Left click it and hold down. And bring it as close as you feel comfortable. After that, you can go down to right below pre-scan and click tip approach. After you see that it's engaged, you'll see that it'll be reading 20 nanoamps on your top bottom signal, same as your set point. Then do a sensor response to make sure that you are actually in feedback. Click on sensor response, which is right below tip approach. You should get somewhat of a linear relation. If you do, then you are in feedback. Click exit. To start a scan, there's these left and right arrows. Click those, and the system will go into scanning mode. I'll start scanning an image. Alright, once you're scanning, you should be able to see if your scan range is high enough. that in your video signal, you'll see the probe actually moving. While on your software, you actually see it acquiring. In this image, you'll see the 20 micron scan size. Right now, we're looking at 10 micron grade XY calibration grading. So each pit's about 5 microns, and the space between it is about another 5 microns. So you'll see from one end of the pit to the other should be about 10 microns. We're doing it at 20 micron scan size at 60 microns per second with a resolution of 300 points. So 300 is 300 points in each line. And that resolution could go up to 1,000 points per line. In summary, some of the things that we went over is just, how to get the laser on the probe, how to align the laser, and then how to approach on the sample in contact mode. We're going to do tapping mode. It will just build up on contact mode. So right now we're assuming you've put the laser on the probe, you've aligned it, you've got them both close to 0, you have a nice good sum, at least more than 10 nanoamps is something that you want to look for. And the first thing you want to do is go to setup and go to tapping mode. And select it. Then you get this new one, tapping mode, shear / dash force. Now before you hit active, you want to make sure that the top bottom signal is selected in the oscilloscope. So you can left click till it says pre-scan, go down to where it says detector signal and make sure top bottom is selected. If you don't do that, when you try to activate it, it will tell you you have some kind of error. So select top bottom and then hit active. After that, you'll have a range. The range is what the frequency sweep will be that you'll be using across your probe. So I think the max is 0 to 600 kilohertz. So if you know what kind of range your probe oscillates at, the oscillating frequency should be on the probe box if you buy from Vico probes. And then that will give you a better idea of what you should be looking for when you do frequency sweep, or at least choosing a different range. The amplitude is the amplitude you'll be applying to the frequency sweep, and then the frequency right below. The frequency is the selective frequency you'll be using for tapping mode, which we haven't chosen until we've actually found the peak and selected it. The input gain is the gain it will be using after it oscillates the probe, the seed, to get a better peak on it. So you can do anything up to 100, I think. 400. You don't ever want to go that high. The highest you ever want to go is 8. An 8 input gain. If you can't get it with an 8 input gain, then you're probably not well aligned, or the probe might be damaged and it won't oscillate. And if you continually have problems with it not oscillating, maybe something's wrong with your Z scanner, or your Z scanner is not tapping, or you might have problems with the controller where the synthesizer board in your controller is no longer giving out a frequency sweep. So let's assume everything's going fine. We aligned everything. Now we have range 0 to 600 kilohertz right here. Amplitude is 0.0. Let's start with 0.1. 0.1 should be a nice good start for any probe. Frequency, it doesn't matter if we haven't chosen anything. And an input gain of 4 is a good start as well. Now, there's two buttons you can select, spectrum and full spectrum. Full spectrum will run the full range that you have selected before, 0 to 600 kilohertz right now. If we zoom in into a specific range, you would only select spectrum, and it will only sweep that specific range that you zoomed in on. So right now we'll do a full spectrum. Oh, we're in phase mode. No, we do not want that. I didn't notice this, but at first we want to be in amplitude mode. So select amplitude. And let's do the spectrum again. And we should start seeing some peaks. So we got 3 peaks. Most likely these 2 are harmonics of the first one. So your natural frequency is the first one. So let's zoom in on it and see if it improves. Because right now we're looking at 0.1 volts of amplitude. Ideally we want an amplitude reading of 5 volts. 4.5 to 5.5 volts is a good range to have for an amplitude on your peaks. So let's zoom in. To zoom in, we first select zoom in. Now it's pressed in. Left click on the window. Left click once on the left side. Right click on the right side. Oh. Left click on the left side. Left click on the right side. And then right click. And once you right click, it will zoom in on that between those 2 selected frequencies. Now we're still not high enough. Now we're reading 1.4, 1.6 volts of amplitude. So let's increase that. We can increase it using the input gain or the amplitude gain. Actually, let's increase it using the input gain. So we'll increase it double. So we change the input gain to 8, and then we'll do another spectrum, which will just sweep on that voltage, that frequency range. Now we're up to 3.32 volts. Okay, still not high enough. So now let's increase the amplitude until we read about 5 volts of amplitude, which we are now. Now we got 4.826, which is good enough. But let's zoom in a little bit more to get a better look at that peak. Make sure it's a nice peak. And that's what you want. You want to show them sharp peak. You don't want something with some dual peak. That might be signs of something maybe is on the probe that's hanging on, or damaged probe, or again, some of the other things where, or maybe it's not even mounted on right, or you don't have a good sum on it, or aligned right. So right now we're reading, let's see, we'll left click on the peak and the red crosshair will appear, or select our amplitude, and that should be giving us a reading. So right now we're looking at 4.874. And when you choose your frequency, try to choose a little bit to the left of the peak, so don't do the apex of it. Go a little bit to the left of it, because once you engage, it will dampen out the natural frequency, so it'll do a little shift to the left. So you want to catch that before you engage. So once you selected your frequency, so right now with the red triangle, you'll see it's at 67.367 kilohertz. And for this type of probe, it's usually between 50 and 100 kilohertz, which is right around the right range of this one, So we know that this is the right peak. So once we select our frequency, we want to minimize it. Don't close it, because closing will turn off tapping mode. So minimize it. Let's see. So we minimize it. It's down here. Now for our set point. Our set point is now a percentage. So a percentage, meaning it will use half of the amplitude, whatever percentage of the amplitude you want as a set point. So if we do 50%, we're reading 4.8, we're going to have like a set point of, what is it, 2.9? 4.8. 2.4 would be our set point. 2.4 volts would be our set point. So the way you want to tap depends on the sample. If you have really soft samples, you want to do lighter tapping. So you would want to use like a higher percentage. So it won't use the full 4.8 volts. You want to use probably like 4.4 volts or 4 volts or something. So you would use a higher percentage. Harder tapping, if you have a hard surface, it doesn't really matter. Or you want to go through some kind of layer that your sample might have, you want to do a little bit harder tapping, you would lose, a lower percentage. 50% right now is good for just default, or you can even adjust on while you're scanning to see what's better for what sample you have. So increasing or decreasing it. You can do it while you're scanning. So right now we'll leave it at 50%. Again, let's move the probe closer to the surface so we don't have to wait as long to engage. Closer remove. The same thing like contact mode, we select tip approach. Now tapping is a little bit more fidgety. You start that thing where we're having some kind of oscillations. So to eliminate those or try to improve that, we want to start adjusting our proportional integral gains. Most likely our integral gain is the one that's causing this, so we want to lower that oscillation. I'll lower the integral gain to lower the oscillations, 0.2. If you can't do that with this probe, you'll see it. So you lower it enough to where it doesn't oscillate very much, or not at all. But you want to go too low where we start losing feedback. So it looks stable enough right now at 2 and 0.06 that we can see how it looks when we scan. So again, we press the left-right arrows to start scanning again. And there we are. So to improve this image, we might want to let's see if we can increase our percentage, see how that affects the sample. All right, let's try it. That was not good. Back to 50. Let's start again. So for tapping, the things you can do to improve your tracking is adjusting your proportional, integral, and derivative gains. Maybe slowing down your scan rate, which is another thing we can do right now. Changing your set point so you have harder or lighter tapping. All that while monitoring your image and making sure it doesn't oscillate. In this particular sample, we're using old probe, so we're not going to get any better than getting some kind of rounded off edges, it looks like. So what he just showed you was more just amplitude tapping mode. So after we aligned our laser, onto our probe and then aligned it onto a photo detector, did a frequency sweep, and then found the amplitude on it, then we engaged on it, on the surface. Now the next Another mode of doing tapping is using phase detection, where you can look at the change in phase values on the surface. So to do that, we'll go back to the beginning to where we did a frequency sweep. All right, so we'll stop the scan by clicking the left, right, and disengage using the motor up button. Click it once and it automatically lifts. Oh, we didn't do that, huh? So we bring back the frequency sweep window by maximizing it again. Let's just do another spectrum to make sure we're still at the right peak. So now we're still seeing the 5 volts on our amplitude. We have the right frequency, everything's still the same. The next step on this one though, we go back to mode and go to phase mode. So we hit phase. Now we have another screen added onto it. Now we want to click on auto phase, would only center our phase to be 0 at our peak. And after we hit auto phase, we want to click the plus 90 right to the left of auto phase 3 times. And this will give us a negative value here on our oscilloscope. After we do that, we want to minimize it. Now the difference is our set point. Our set point now is our number, negative 64 nanoamps. Of course, we can't reach negative 64 nanoamps. That's just a default number. What we want to do is left click on the oscilloscope and look at our value, which is negative 31.66. And it should always be a negative value. Once you click the 90 button, the plus 90 button 3 times. Now we can change our set point according to a nanoamp reading. So instead of 31, instead of using 50%, we'll do a negative 15 nanoamp. So we'll see a difference of negative 16 nanoamps as our set point. So we go back to set point, highlight it, and we'll do a negative 15 nanoamp. Now, to look at the phase signal, we go to acquire on the top menu, go down to phase imaging, and it should add another window called phase. And just like that, same thing as we did in contact and the regular amplitude tapping. After we've changed our set point to about half, we can engage. So we have to left click again here until we hit pre-scan and hit tip approach again. Oh, we're too far. So let's move the motor closer. Now we can do it. I added a derivative of 0.1 and see if that improved it, and it greatly improved it. Let's auto scale that. I'll leave that at full. So that added phase signal add-on allows us to see the phase changes between the oscillating frequency and whatever after it's any kind of phase shift after it's hit the surface, and that's what our phase signal gives us. And that's pretty much the phase tapping mode on the caliber. So After we do the amplitude sweep, find our peak, select phase mode, click on auto phase. After that, click 90 3 times, which will give you a negative value on your oscilloscope. Do whatever you want for your set point, as long as it's between 0 and the negative value that you read on the oscilloscope. So again, the more negative it is, the lighter the tapping. The less negative, the harder the tapping. So you're going to be pushing harder on the sample with a less negative number, as opposed to a higher negative number, which will be a lighter tapping, which would you probably use for like a softer surface.